Hydrogen is the name of one of many elements named in chemistry. In Latin terms, hydrogenium. The verbal derivation comes from ancient Greek, where hydro means water and genes forming. It is the first element ordered in the first group of elements in the periodic table as atomic number 1, first period, group 1, or simply H. Scientific research shows that hydrogen is the most common or abundant element ever found in the universe. There is evidence of the existence of the hydrogen element within nearly all organic compounds in chemistry, most notably the chemical structure of water, where 2 units of hydrogen atoms are linked with 1 oxygen atom. Like many elements, hydrogen can be formed in a different phase of matter, or in dyslexic terms, a different state. Its normal phase is in a gas form at standard temperature and pressure. Its temperature is found to be far below the freezing point of water as a solid. The melting point of hydrogen is measured to approximately below 259.14 degrees Celsius. The boiling point is found to be not too far above that, from which it is measured at below 252.87 degrees Celsius. Hydrogen is also the lightest element in existence. The atomic mass and density is far smaller than atoms of oxygen, which suggests its ability to create a lifting force. Also listed are its other measurements. The initial discovery of the element was discovered by Swiss-born physician, chemist and alchemist Philippus Aureolus Theophrastus Bombastus von Hohenheim, or simply Paracelsus. His findings date back to the 16th century, where he actually performed experimenting the chemical reaction between metals mixed with acids. At the time, Paracelsus was unaware of the gas he actually produced was hydrogen gas, or simply H2. Later on 1671, natural philosopher Robert Boyle described the reaction between iron fillings and dilute acids which resulted in the production of H2. 1766, British scientist Henry Cavendish first recognized H2 as a discrete substance by identifying the gas from this reaction as inflammable and found that the gas produces water when burnt into exposed air. Although stumbling onto this discovery during an experiment, he initially assumed that hydrogen was a compound of mercury, but Cavendish still managed to accurately describe several key properties of the element. Well-renowned nobleman dubbed the father of modern chemistry, Antoine Laurent de Lavoisier, gave this element its name we know of today. In addition, he proved the presence of hydrogen and oxygen that makes up of the water structure. One of the first uses of H2 was for balloons. This was obtained by using sulfuric acid and iron as producers of the reaction. However, these days we use the alternative, namely helium, which comprises double the subatomic particles of hydrogen and is presumably much safer. It is considered that the simplicity of hydrogen's atomic structure has been the main basis of the theory of atomic structure in general. A notable mark in history is the disastrous explosion of the LZ-129 German Zeppelin, or more popularly, the Hindenburg airship, not to be mistaken with non-rigid airships commonly known as blimps. A total foundation went up in smoke as the Hindenburg made its way to land at the Lakehurst Naval Air Station in New Jersey, May 6, 1937. 36 people were killed in the accident, surprisingly a total of 33% death toll of all those on board. This footage was clipped from the silent news coverage narrated by American reporter Herbert Morrison. Here's an excerpt of the radio report.
Get it started. It's rising terrible. Oh my, get out of the way, please. It's running, bursting into flames, and it's falling on the mooring mast, and all the folks between us. This is terrible. This is one of the worst catastrophes in the world. Oh, it's like 400 or 500 feet into the sky, and it's a terrific crash, ladies and gentlemen. The smoke and it's flames now, and the flame is rising to the clouds, not quite to the mooring mast. Oh, the humanity and all the fans are screaming around it. I told you, I can't even talk to people. There's fish on there. I can't talk, ladies and gentlemen.
The element is composed of a single proton and a single electron. The presence of the neutron varies between different forms of hydrogen, whether there be one neutron or none. It is said that hydrogen is abundant in space, but essentially absent on our planet, namely because it dimerizes between everything else. Examples of this are found in various chemical compounds containing hydrogenic atoms, namely the following: acetic acid, best known within vinegar; water, the majority of Earth's covered surface; and ammonia, a toxic and corrosive compound and an ingredient of glass cleaners. Hydrogen has no smell, has no taste, cannot be seen, is colorless, is a non-metallic element, and is univalent in atomic bonding, where it forms a single bond with one other element. Hydrogen is also considered a diatomic element, where its characteristics could be useful as fuel cells. However, this requires large amounts of pure hydrogen, an expensive and demanding process. Hydrogen is also one of the more notorious elements for easily bonding with other elements in chemistry, hence the definition dimerizing. The definition for this action is mainly caused by the intermolecular attraction force caused between two partial electric charges of opposite polarities. It is said to be weaker than the ionic covalent bonds. Generally, this is evident with the bonds between the following elements: oxygen, nitrogen, and fluorine, all of which are strongly electronegative heteroatoms, meaning that either one of those plus hydrogen easily produce compound. In short, hydrogen is atomic constituted within many chemical compounds. Hydrogen is ubiquitous in the universe, but surprisingly difficult to produce in large quantities on the Earth. The scientific view of hydrogen's existence. It is said to be found in large quantities in space, notably within the gas giants and in stars, all of which are a hell of a long distance from Earth. Hydrogen is common in our planet, yes, but its characteristic to dimerizing into various organic compounds does not constitute its usability in its purest. Meaning, to obtain pure hydrogen from such compounds is an expensive process, and with our current technology, involves heavy processing using other means. One example is the process of splitting the hydrogen. In truth, this process involves the use of electric charged water being put through a process of splitting the compound and output. The general outcome? A much more reliable form of fuel cell, almost too good to be true, but it's not impossible for it to be a genuine alternative to carbon. Despite the microscopic size of hydrogen atoms and its presence in a form of compounds, doesn't necessarily mean it's a harmless element. Its violent reaction with elements such as chlorine, oxygen, and fluorine defines its combustion characteristic. The invisible explosion increases the risk of harm from hydrogenic bonding, such as gas leaks. Here is the table from before. This time round, there is more information included for your use. Let's recap on what we should know by now. Hydrogen is the smallest element in chemistry, containing one proton and electron, the neutron barely present. Hydrogen has no taste, has no color, almost invisible, has no smell, is highly flammable, is a non-metallic element, and has a single bond between elements. Hydrogen is commonly found within various numbers of compounds such as water and ammonia. Hydrogen is commonly found as a pure substance in space. Hydrogen's solid and liquid phases form at temperatures far below the freezing point of water. Hydrogen is a diatomic element and is easily dimerized with other elements. Hydrogen is a potential combustible resource for fuel cells, but not at this time of age. Hydrogen can be produced from a chemical reaction. Hydrogen is atomic constituted with other chemical compounds. To conclude this short informative, remember that hydrogen is one of 103 total number of individual elements in chemistry. Let's have one last look at the periodic table. Then, we'll find a similar element in the same group of hydrogen. Wait, the rest of the elements in group 1 are all alkaline metals. So, let's move on to the next element on the other side then. Ah yes, helium. With only double the atoms, helium is actually the second lightest and second most abundant element in the universe. It is also found in space, particularly in the Sun, caused by nuclear fusion of the proton-proton chain reaction and C&O cycle from hydrogen. Other than that, helium is also a lifting gas as it is lighter than oxygen. It has no color, no smell, no taste, except this is defined under noble gases where hydrogen is undefined. Helium's boiling and melting points are actually lower than hydrogen's. Interestingly enough, this element does not exist in solid or liquid forms. However, at extreme low temperatures, it is defined as a superfluid, a frictionless phase of matter with unusual properties. Otherwise, helium is found within mixtures of gases which can be purified for commercial use, such as airship inflation, arc welding,
squeaky voice, and party balloon inflation.
Yay! Goodbye.
Hindenburg! Thanks for listening.